FastMCP 3 implements reactive state management through a declarative Rx pattern, enabling dynamic UI updates via conditional rendering and event-driven state transitions. The framework's reactive primitives, such as Rx and result, facilitate real-time UI synchronization with backend operations, while action chaining ensures atomic state updates across asynchronous workflows. You will now observe how a button component's visual state and interactivity are controlled through reactive state binding, where a loading indicator toggles via SetState actions during an asynchronous CallTool operation. The code demonstrates the initialization of a reactive state variable, its integration with UI component properties, and the orchestration of success and error handling callbacks to maintain UI consistency. From prefab UI, actions import SetState, show toast. From prefab UI, actions, MCP import CallTool. From prefab UI, components import button. From prefab URX import result, Rx. Saving equals Rx saving. Button. Saving, then saving. Save. Disabled equals saving. On-click equals. Set state, saving true. Call tool. Save data. On success equals. Set state, saving false. Set state result, result. Show toast saved, variant equals success. On error equals. Set state, saving false. Show toast failed, variant equals error. Hash pass state equals saving, false to prefab app when returning. This code demonstrates reactive UI state management using Rx for dynamic button text and conditional rendering. The saving reactive variable controls both the button label and disabled state, creating a responsive loading indicator during async operations. The pattern uses action chaining to manage UI state across async workflows. When clicked, the button first sets saving to true, then calls the server tool. Success and error handlers both reset saving to false, ensuring the UI remains responsive regardless of outcome. This approach prevents duplicate submissions while providing visual feedback. The design separates concerns cleanly. Rx handles reactive state, SetState manages updates, and CallTool bridges UI to backend. The result reference enables direct state updates from server responses, while the action list ensures atomic UI transitions. This pattern is particularly effective for form submissions and API calls where loading states improve perceived performance. Let's break it down. From prefab UI, actions import SetState, show toast. Imports two UI action classes from the prefab UI, actions module, SetState for managing component state, and show toast for displaying temporary notification messages. From prefab UI, actions, MCP import CallTool. Imports the CallTool class from the prefab UI, actions, MCP module, which provides functionality for invoking tools within the FastMCP 3 framework. This class is specifically designed to handle tool calls in the MCP multi-component processing action system. From prefab UI, components import button. Imports the button class from the prefab UI, components module, making it available for creating button UI elements in the current scope. From prefab URX import result, Rx. Imports result and Rx from the prefab UIRX module, providing access to reactive programming utilities and result handling mechanisms. Saving equals Rx saving. Creates a variable named saving that holds a reference to a reactive stream or observable named saving. This appears to be using a reactive programming pattern where Rx is likely a factory function that creates or retrieves a reactive stream by name. The immediate effect is the creation of this reference, though the actual stream behavior isn't visible in this line.
Button
Creates a button widget instance with unspecified parameters. The button class is typically used to create clickable UI elements in graphical interfaces, though the specific configuration and behavior aren't visible in this segment.
Saving, then saving. Save.
Calls the then method on the saving object with two string arguments, saving and save. This appears to configure a pending state message, saving, and a completion label, save, for an asynchronous save operation, likely updating UI elements to reflect the operation's progress and final state.
Disabled equals saving.
Disables the saving functionality by setting the disabled parameter to the string value, saving. This configuration likely prevents the system from performing save operations or persists data to storage.
OnClick equals. Set state, saving true.
Sets the state variable, saving, to true when the click event occurs. This is part of an event handler list that executes multiple actions sequentially, with this being the first action to trigger a saving state indicator.
CallTool
Invokes the CallTool function with no visible parameters, initiating whatever operation or workflow this tool is designed to perform. The exact behavior depends on the tool's implementation, but this line specifically triggers its execution without any custom arguments or configuration.
Set state, saving false.
Sets the state variable, saving, to false, updating the application's internal state tracking to indicate that no save operation is currently in progress.
Set state result.
Sets the state variable named result to the value of the result constant. This operation stores the result value in the state dictionary under the result key, making it accessible for subsequent operations that may need to reference this result.
Show toast saved. Variant equals success.
Displays a success toast notification with the message saved. The variant parameter is set to success, which typically styles the toast with a green color scheme or success indicator.
Show toast failed. Variant equals error.
Displays an error toast notification with the message failed. The variant equals error parameter specifies the visual style as an error notification, typically rendered with red coloring or an error icon. The reactive state management pattern in FastMCP ties together UI responsiveness and backend operations through declarative Rx bindings and action chaining. The saving reactive variable serves as the single source of truth, dynamically controlling both the button's label via then and its disabled state, creating a cohesive loading experience. When the button is clicked, the sequence begins with SetState immediately updating the UI to a loading state, followed by the asynchronous CallTool operation. The success and error handlers both reset the saving state, ensuring UI consistency regardless of outcome, while result and show toast provide appropriate feedback. This pattern cleanly separates concerns, reactive state management, UI updates, and backend communication, while maintaining atomic transitions through action chaining. The design prioritizes user experience by preventing duplicate submissions and providing clear visual feedback, making it particularly effective for asynchronous operations like form submissions.
The set state juggles tomorrow's state, while CallTool digs for buried results. Yet the button stands still, holding its breath